Unit 3 is transformations. This is lesson 3 for compositions of transformations. As examples, notes, there's one problem, just like you're going to be required to do for part of the assessment for Unit 3. Composition of transformations. Here's the example. Transformations with a quadrilateral. We're going to graph the quadrilateral on the coordinate plane below. It's actually on the next slide for me, but below for you. Making sure to label each vertex appropriately, please. Perform the indicated transformations while filling in the chart and graphing. Label all vertices for each step. So we have our original figure. That's our pre-image. It's LEHS. L is the 0.15, E is the 0.43, and H is the 0.76. Wrapping it all up, S is the 0.38. Now we're going to reflect over the y-axis, and we have our rule, negative xy, which means they're going to stay in the same positions, but the x values are going to change signs. So there's all the original x values changed signs, and the y's are just going to stay the same. We're going to graph that, and we're going to graph that in green. The original was black. Next, you have to do a rotation from the image we just got. Okay, we're not going back to the original. We're doing this in composition, which means we're doing them right after the other. So rotate 90 degrees counterclockwise. Here's our pattern. So we have the opposite of y now in the front, and all the x's just move to the second spot. So take all your y's and change the signs and put them up front. Grab all your x's, don't change any signs, and put them last. Now we're doing a translation using the vector 11, -2. So we're going to take from the blue shape that we just graphed. We're going to add 11 to all the x's and subtract 2 from all the y's. So add 11 to all the x's, subtract 2 from all the y's. Let's graph this. So first of all, we're going to start with our original shape, LEHS. There's L, 1,5, E's 4,3, H is 7,6, and S is the 0.38. So there is our pre-image, our original. The first transformation is to reflect over the y-axis. We already found where those coordinates are going to be, so we just need to graph them. -1,5 is L prime. -4,3 is E prime. -7,6 is H prime. And S prime is going to be -3,8. And that is our second figure, first image, and that should be shaded in green. I'm going to go to the next slide. I have the original and the second image, and now we're using the green, of course, to get to the blue. We already figured out what those were. We just need to graph them, and these are going to be L double prime, E double prime, H double prime, and S double prime. Make sure you are labeling them correctly. So -5 and -1, we're rotating 90 degrees counterclockwise. So -5, -1. E prime is at -3, -4. H prime is at -6, -7. And S prime's at -8, -3. And there it is. These are congruency transformations. Okay, they should be the same shape and size. Orientation can change, but they should all be congruent, and they look congruent, so I think we're okay. Now let's take our blue and go to the purple with a translation. So we're going to go right 11 and down 2, and we already found those points. This will be L triple prime, E triple prime, H triple prime, and S triple prime. Here we go. L triple prime is at 6, -3. E triple prime is at 8, -6. H triple prime is at 5, -9. And S triple prime is at 3, -5. And it looks the same. It was just slid to the right and down. Okay, so make sure your lines are straight. You have all your vertices labeled appropriately. And this will be 40-point major when you do it for your assessment. Not this, this is the example. Probably turn it in. Here's some more types of rigid motion. Any rigid motion is either reflection, translation, rotation, or glide reflection. And that's where there's a composition of a translation and a reflection. So here's some different types of notation that we have not seen before. I just thought I would make you aware of them. So lowercase r subscript m is going to be a reflection of a triangle ABC across a line M. So that's what the M is, the subscript M. Lowercase r is reflection. Okay, here's a translation. There's our notation for it. Capital T is translation, and they use the vector. So in this example, that diagram is using a vector, -2, -3, and we are doing this to triangle ABC. So we're translating triangle ABC using the vector on -2, -3. Here is a rotation. So this is capital R. Now we do have a subscript here as well because we have the angle of rotation and the point, the center of rotation. So we're rotating triangle ABC so many degrees using P as the point of rotation. I'm assuming by the diagram it's always going to be counterclockwise unless they tell us it's clockwise. Now a glide reflection. There's the example of the notation. First, you're reflecting the triangle ABC across the line M. Second, you're going from that and you're translating that result from step 1 using the vector for 0. And that is the notation. That little o, raised little o, is a mathematical symbol for composition of functions. You will see that more in Algebra 2. All right, identify the line of reflection, write the equation of the line. We wrote equations in Unit 2. A little bit of review. Right in the middle of those is the y-axis, but they want the equation, so that's x equals 0. But of course it is the y-axis, but that's not an equation of a line. Looking at number 2, we've seen this line of reflection before. It's not one of the axes. It is over the line y equals -x. That line is going down to the right, right through the origin, slopes -1. Number 3, that looks like it's a vertical line of reflection. So that will be x equals -3. You can go from r to r prime, q to q prime, and find the part that's right in the middle of those, because each of the corresponding points should be the same distance away from the line of reflection. Okay, let's look at number 4. It's a horizontal line, so it's going to be y equals something. It's not the x-axis because that pre-image is up farther. So we could count between the corresponding parts and find right in the middle. And that is right in the middle. From point Z to that line is 3. And from that line to z prime is also 3. Okay, there's our line. It's y equals 1. Number 5, right in the middle, kind of easy to see with j and j prime. Vertical line right there, x equals -2. And this is just the x-axis. Of course, that's not an equation. It is y equals 0 is the equation of that line.